So thank you everyone for joining. I'm glad to see more students and new members. So we already covered the topics on different operators, different basic data types. We tried to create a functions, and now it's time for us to learn about the control of a flow of our programs. So we can control the flow by using the if-else statements, one of the way. So let me explain first the if-else statements, and then we will try to solve some problems. So we will have interactive session today. So you can see here the code, which so we create the variables, the integer variables birth year, the current year, and some and we are printing some strings. Yeah, so we want to know the year, the age of some person. For example, we subtract the current year and we subtract the birth year from current year, and then we print how old is someone. And because we use the quotation marks, it's going to be a string. So this is the type conversion method. So let's see how we can control the flow of printing some statements depending on the truthfulness of the statement. So after we calculated the age, we can check whether a person is older than 65, and then if it's true, then we print the enjoy retirement. The person will retire. So when we print the if statement, when we use the if statement, then we check the condition. And if the condition is true, then the next statement will be executed. So the next statement is print the enjoy retirement. If the statement that we evaluate is wrong, then we will skip this statement and go on further on our program. And we will just print you are some age, yeah, some years old. So let's execute this program. So imagine so the program flows from top to bottom. Now we have a global variable created, which is the birth year. Then we create the global variable current year. Then we check then we calculate the age, and then we check if the age is bigger than 65, then we should expect the statement enjoy retirement in our program output. If not, then we will have only this statement, you are and some years old. And we see here, we see only this statement, the last one, because 31 is less than 65. The evaluation results in false, then we have only this statement. Let's see another program. Could you please calculate or share what will be the result of this program? Do you understand what's going on here? You can, if you know the answer, please just unmute yourself and free to share your opinion. So it's the same program, but something is changed here. We changed the birth year. It was 1982. Now it's 1928. What's going to be in the output?
I think it's gonna be enjoy retirement, that print statement, because our if statement is.
So let's check it. We have the first variable, global variable created, the second variable created. Then we calculate the age. Then we check the statement here. And because subtracting 1928 from 2013 results in 85, which is bigger than 65, we will have enjoy retirement statement. And then we'll have still the last statement because it's not, it's just a statement that prints the age, and it's not what depends on any condition, right? I see some results here. Okay, why there are space? Because there is actually space here. I cannot change it, but there is a space here and here and here. So maybe it's not clear from this simulation, but there is space. Okay, thank you. Let's go further. What do you think will be the result of this program? There is some small changes in the code, and I think it helps us to better understand some data types, type conversion, operation on data types, some basic operations. Any ideas? What's going on here and what will result in the output? If comfortable, we can just go through the code and say what we have from each line of code, if you want. Not just the answer. Anyone like volunteer here? Okay, Aman Kumar says we're gonna have enjoy retirement. Then you turn 100 in 1928 and you're 85 years old. Okay, let's go through code line by line. So we first create the variable, integer variable, birth year, then the second variable, current year. Then we calculate the value of a new variable age from the previous variables, right? Then we check the condition. And if the condition is correct, then we will have two statements, enjoy retirement, and then we will have the statement you turn 100 in, and then the answer will be 100 plus the birth year. So here is the integer operations. Yeah. And then we'll have the statement about how old someone is. So let's check it. So we have 85, which is true. Then we'll have all three statements in the output. Okay. If it's clear for you, if it's easy for you, let's go for a some kind of problem quiz. And this is the quiz. So we have bricks and we want to create a brick of some inches long. And for creating of some inches long bricks, we have some small bricks and big bricks. Small bricks are 1 inch long and big bricks are 5 inches long. We need to return true if it is possible to make a goal. This is the goal, our result, by choosing or by collecting small and big bricks together. If it's true, then we should return true. If we cannot make the goal from small and big bricks, then we should return false. So we create the function, and last time This is Java. Okay, let me check the Python. Oh, no, no, no. Okay. Maybe it's in the Python logic. Sorry, I lost the link with the correct. Okay, it's here. Okay, so last time we already learned the syntaxes of definition of function. So we have the def conserved word. Yeah. Then we have the name of a function. We sometimes have the parameters here, and we need to define this function. What we need to do inside the function. So if you understood the task, then I'll give you about 3 minutes to solve it. Oh, interesting. So Abdullah shared new information. So if we have the comma separator for a print function, it will add a space between the string. It's interesting. Maybe we can try it in the code simulator. Let me try somewhere here, for example. Yeah, it works. Okay, we have first solution from Dimaral. And does anyone needs more time to solve, or we are good to discuss? If somebody didn't understand the problem, just speak up and I'll repeat again or explain again. Okay, we have one more solution. It's not the solution. Okay, we have a problem here. I'm this age, oh, but it's not. I'm this age old. Let's check it. Let's check it. Okay, let's check one more thing and then we will discuss the problem. So Aman, I think, no, Kilwa asked about two statements, print statements. One of them gives a mistake and one of them not. And why is that? So let's check it. Let's run it here. We don't need this one. Okay, did you define age? Yeah, it was a integer. I see, because maybe because we didn't convert it. No.
But issue is I'm just sure to get that's 65 years old. You have to typecast it, but
So the difference is using plus or comma sign, common operator
yes.
here. Maybe because we can't sum up integers with strings, right? We need to convert integer to string and then sum up it, right? We should use like this, for example. It works. No. Age old. Stra. Yes. Okay. Yeah, now it works. So we can't sum up integer with string. We need to convert either to integers, everything, or to strings, everything. And here the comma, it means we just list everything that we want to print. And I guess it prints 65 because it automatically converts it to string. I think I need to Google it, but I think when we state here the string, in general, in print statement, we should everything have of the type string. Let's check it like this, if it works. Yeah, it works. So it automatically converts it to string, right? Or it doesn't convert to string, it's integer, but we just print integer, right? Or we can list everything that we want to print. And plus sign is an operator. And by knowing the conditions when we use the operators, like mathematical operators plus, helps us to understand what's going on here. So, for example, we have name, and it's your name, for example, and we list everything that we want to print. It's okay to use the comma separator here. Yeah, does it work?
String should be in quotation marks.
Yes, yes, yes. Thank you. Yeah. So we just print everything here. But when we use plus operator, we apply rules, mathematical rules when we use integers or some operation on strings. That's why we can't just leave it like this, age. Yeah, because it's string and it's integer. Is it clear?
Yep, thanks.
Thank you. Let's go to our problem here. Let me check. Do we have other solutions? Okay, let's check the first solution that was suggested by Demaral. So she thinks that we can, oh no. So she wants to create the first variable goal, which is going to be a sum of small and big arguments that we received here. Then she wants to check if goal is bigger than 8. Then we need to print true. Okay. Let's run this code. We have the comment, the bad code, because it doesn't have a return statement. So we need to return. Okay, I see. Don't print, computer return, and compute and return the result. Okay, let's just make small. Okay, so it doesn't pass any of our test cases, but that's all right. Let's see what's going on here. So first of all, let's understand the program. So we receive 3 integers. First is small number of small bricks, for example, 3, number of big bricks, for example, 1, and the goal, how big we want our resulting brick to be. So we construct a bigger brick from small bricks or from big bricks. So we don't need actually to calculate the goal because we already know its size. It was given us by the arguments. Yeah, we already know it. Okay, so let's delete this. We need to use if statements to check. And if we need to check something, evaluate something. And if the statement is true, then we should return true. If not, we return false. So here, how can we check whether the number of small and big bricks will result in the construction of a bigger, like, I don't know, house with the defined value 8, for example. So if we evaluate goal bigger than 8, then what it does is just evaluates whether the value that we received by the argument is bigger than 8. But actually in our condition of a problem, we don't have any of these statements. We don't need to evaluate whether the goal is bigger than 8, right? It's just one example, because sometimes the goal might be equal to 8 or 9 or 10, but it's not our goal. We want to compare whether these two values, the number of small and big bricks, result in the value goal. So if, for example, we have 3 small bricks, and we know that one small brick is 1 inch long, then we will have, summing up, constructing 2 small bricks, we will have 3-inch bigger construction. Then we see next big bricks, number of big bricks. We have here 1, and we know that big bricks are 5 inches long. So if we have just one big brick, which is 5-inch long, and we add to our 3-inch construction, we will have total 8 inches big, 8 inches long construction. So 8 is equal to our goal 8 here. Yes, our goal is here, third argument. And if 8 is equal 8, then we should return true. If the construction that we created was bigger than the goal or smaller than the goal, then we should return false. Now, if the explanation is clear, do you want to have more time to try and solve this problem? Like 2 minutes? I think it's very important to try and solve yourself, even if it's wrong, because you then will understand the solution and you will remember the solution better. So I will give you, please give me a feedback if you need time. If you don't, then we will just proceed further, because if you just are all silent, I don't understand what's going on. I can't understand where are we all like staying, or oops, I can't see you anymore. So if you want more time, like 1 or 2 minutes to think about it, thumbs up or just unmute yourself, say, okay, let's do it. And if not,
Ma'am.
yep.
Ma'am, I said one answer. Could you check if it's true?
Oh yeah, I just wanted to give more time for others to try and solve before we
Okay, ma'am. I got it.
okay, more time. Okay, please try. And while you are trying, I'm going to start with the Aman's solution. We will check it first and then go next. Okay, you changed a little bit. Let's use your second answer, right? Or we can check both of them actually.
Yes, my first one was not showing the answer. That's why I changed.
Okay, then I'll use your second answer. I already see the same mistake. So everyone, please pay attention that we don't need to use print statement because we tried already and the program said that we should use return. We should just return true or false. I'll change return here instead of print for you. And then you have, okay, you just checked. Okay, we have one more solution by Dimaral. Good job. I think it's very good that you're trying, no matter that the first one was false. Please, Rivati, Abdullah, paste any code that you have, just so that I know. Can you write the if statement? Can you write function or your logic? What do you think about this problem? It's interesting to see. And while you're pasting your solution, I will try to explain Okay, I'll try to explain the solution by Aman. And Abdullah asked, does the goal size has to be exact? Yeah, we actually know the goal. So let me explain again. So here is the example of the function call. So when, as I explained you in the previous study jam, when we create a function, it will not be executed until we call it, right? Here in this web application, I run Go. That's why this function runs. But if it was any of our environment, we should have here written a function, which is make bricks, right? And then some functions does not require any arguments, right? We could just call it like this. But our function make bricks requires 3 arguments. So we need to pass like a ball. We need to pass 3 balls, right? So that's why they give us just example. What can we expect our arguments be? And what should we expect the outcome be given these arguments? So in the first example, we have 3, 1, 8. So it means we know what is the number of small bricks, big bricks, and what is the goal of our construction. Yes, how many, what's the length of the construction, which is 8. So answering to your question, does the goal size has to be exact? It is exact. Yeah, we know it's 8, or it can be 9, 10, any number here. But we don't need this statement in this case. Okay. Okay, we have an example solution by Revati. It's okay that you got an error. Actually, in programming, you will encounter many errors, and it's part of your experience to get rid of these errors by asking someone or by yourself. Put 2 space bridge.
Yeah. I tried it, but it was successful at the second attempt.
That's great. Okay, let's see this example by Aman. So he creates the variable x, and he calculates the number of, okay, so he calculates the goal, right? So he calculates the result, and then he wants to compare if the result is the same as goal. I think it's great attempt. Let's see the, okay. So he passed most of our test cases, but he didn't pass 4 cases. Let's see what are these test cases. Imagine we have, okay, these arguments, 3 small bricks, 2 big bricks, and 9 is our goal. If we calculate x here, which is going to be 1 multiplied by 3 is 3, then 2 multiplied by 5 is 10, and total is 13. So x now is 13, and it is bigger than the goal. So you have true here, but it is not correct, because we should have true only if it's possible to create. So I think it should be, maybe it should be like this. Let's go. No, then we should understand better why this test case didn't work. Oh, it's false. Yeah. So okay, 13. X is, oh, okay, I see why it didn't work. So the first test case checks if we can create the goal, right? And actually, we should have the second test case condition, which is if we have more bricks than our goal. And if it's true, then we should return false. So we can write here if oh, actually, you already checked it. If it's smaller or bigger, let's see. Okay, if x is bigger than goal, true, false. Okay. Let's try. No. Any ideas? So we should check two conditions. First is whether we can construct the goal, and the second, whether we have more. I see. So I remember the goal of this this problem. So first, we need to, when we check whether we can construct the goal, this is correct, yeah. But then we should check whether we have excessive number of bricks, and how we can check it. We evaluate whether the goal so the goal mod big is the number, the remainder, right? So if we have 9 here, we divide by 2, it's going to be 1. And if this number, remainder, is bigger than, if a small number of bricks is bigger, small bricks is bigger than the remainder, then we should return false, because we have excessive number of bricks, and otherwise we return true. Okay, let's check it by 0.
It should be 5, no? Big. Because big is the number of bricks we have for big bricks.
Yes. Okay, thank you. 5. Yeah.
Not multiply, just goal modulus 5. Not multiply big.
I see. Maybe. And we still have the same number or bigger. Okay, what we left here, so if it's like this, then okay, and then if it's smaller, if x is smaller than goal, otherwise true. Let's try. No. So let's try again and see the number of test cases we should check? Oh, why is even
It should return true, I guess, last line, and otherwise false.
yeah, I see. Yeah, because if it's small is big, no,
Some can plus
not-
sum up.
no. So if we have
Give it a try.
small,
Give it a try.
okay, thank you. Return false, yeah, okay, no. Because if we have, so you think here is false and true? No, we are just guessing. No, it's not wrong, and that's the correct, let's say, approach. So first we check if we can construct the goal from our bricks. If it's the same length, then it's true. Okay. If I see, maybe this. No. Oh, Elif, I forgot. Okay. If we have number of small bricks bigger than goal divided by 5. I see. It's not good. It shouldn't be goal divided by 5. Big. Like this. Okay, let's try again. By 0. 9 divided by 1 is 5 is 4. I have no idea. Let's see other examples. Rivati, is your answer is correct? And if not, we just see the solution because I forgot what's going to be the solution for this. And let's check it. Okay, let's check it
I
here.
think it gives the same result as previous one. Like half of them are okay.
Okay, let's see then the solution quickly because I think I took more time than expected. Okay. Let's see his explanation. Okay.
Wait, so I'll say field number 2 is
Oh, sorry.
not
I'll change the speed to normal. Okay. Okay.
and really, so the other way that this could fail is
So we need to check the first
we get
test
to the bottom.
case. And the answer.
Just line everything. I'm going to look for forms of failure. So sort of what I'm saying here is like, well, fail number 1 is just like not enough. We just don't have enough bricks at all. So I'll say if the goal is larger than what's just the total amount that we have. And I would say that that is, it's big times 5 plus small. That's like just line everything up we have. And if the goal is bigger than that, then it's just clearly not possible. So I'm going to say return false. And here I'll just put return true at the bottom. And as I said, I'm going to try and think about the different forms of failure, and I'll return false. And if we get to the bottom, we'll say return true. So let's just try this. So already this does like pretty decent job. So then the case.
Okay, so this is the same result that we have actually here. 4 test cases didn't pass. And I think his approach is to check all the test cases that brings us to false outcome. And the first condition, he wants to check if we have not enough bricks. Yes. So if the number of small bricks and big bricks end up to be less than the goal, then it definitely should return false. So that's why he checks whether the goal is bigger than the statement here, big bricks multiplied by 5, the length, and small plus small. And the second condition is going to be if we have some extra bricks, right?
Cases we're missing, I assume, have to do with the small bricks, which I haven't really dealt with yet. So I'm going to hit the back button here for a second with my outline. So the other way that this could fail is if there's just not enough small bricks to make up that last little bit. And really the way to compute that is goal mod 5. So for example, if the goal is 16, then I need 1 small brick, or at least 1 small brick. And if the goal is 19, then I would need at least 4 small bricks. So it just happens the mod operator gives us that last little bit. So I'm gonna think about how to fail that way. So I'll say fail number 2 is not enough small bricks. So I would say, well, if, what was it, goal mod 5, so that's the number of small ones I need, is bigger than small. So for example, if the goal is 18, so then that case, goal mod 5 is 3. So we're saying I need 3 mod, but really the number of small bricks I have is 2. Then it's just not possible. So I'm going to say return false. So let's try it. So actually, that does it.
Okay, so one thing that comes to my mind when I see this solution is that when we check whether we have less bricks than we need, it seems natural that it's going to be false anyway. Doesn't matter whether we don't have big or small bricks. And I think checking up for more bricks that we have seems more logic for us. Maybe that's why we were thinking if we have more bricks or if we have less bricks, but we didn't check whether we want whether we lack small bricks, right? So if this is clear for you, I think we have about 7 minutes to try similar problem to just strengthen our understanding of if-else statement. So the second one is about chocolate, actually. Yes. So we want to have a package of some chocolate, and we have small bars and big bars. So we need to return the number of small bars to use if we have big bars before small bars, and return -1. So it means like false if it can be done. So it's the same structure. We have our small number of small chocolate, big chocolate, and then we have a goal. And if we so we need to return the number of small bars. So we return here 4, the number of small bars, because we want to we can construct the 9. I think this is the problem. Let me check it. Return the number of small bars to use. These big bars. Okay, yeah, the same problem. But instead of returning true or false, we return small bars if we can construct the goal, and we return -1 if we cannot construct our goal, instead of false and true. So if we have, for example, 4 small bars, 1 big bar, so in total, we will have 4 multiplied by 1 plus 1 multiplied by 5, and it results 9. 9 equals to 9, then we could construct the goal. That's why we return the number of small chocolate bars. It's 4. And here we have 4 plus 5, which is 9. It's less than 10. That's why we return -1. So it's almost identical problem. We just need to return different statements. And you have only 4 minutes or so to solve it. If you didn't understand the solution of the last problem, please just tell me and we will discuss this solution again and end up our study jam today. Okay, then here is 4 because we use both 4 here. Yeah, all 4 here, and here is 2 because we will use 2 packages. So 7. So we only use 2 from available 4. Yeah. So let me try to write code here. If so the first statement, whether we don't have enough bars. Yeah. So we have small plus big and it's less than our goal. If it's less than our goal, then what we should return?
-1, I think.
-1, yeah. And the second condition that we need to check if so let's try with one condition and then the second condition is that if we can construct then return how many small bars we will use. Yeah, so if go divided by mode, right? If we have 2. No, it's 5. So it's going to be the remainder, which is how many small bars we should use. If it's smaller than, I think like this, smaller than small, number of small bars, then we should return small minus this. Let's check it. Okay, we only passed some of these test cases. Let's see here. We have 9 total. We divided by 5, which is 4. And then, oh, I see. Okay. More test case. I don't think we should have more than 2 conditions. Then something is wrong with our code. Let's check kilo answer, and then if it's not correct, then I will just quickly show the solution by this by the oops. So we have here if O is bigger than 5 big. Interesting. Okay. Then we return, and then we create the variable s, O minus, oh, okay, minus 5 big, okay. Else, we want to know what's the remainder, and then he wants to check if calculated s value is smaller than number of small bricks. We return s, or I think it's going to pass some of our test cases, but not all. Let's check it. Oh, compile problem. Indentation doesn't, maybe I made the mistake.
I guess else has a problem. Else should be in start.
Here, like this?
Yep.
Okay. No. Maybe this one was correct because it automatically creates it here. No. If else, and then if return, no, not correct. Oh, I understand, because I used, yes, I used just space. Okay, it passed majority of our test cases. Yeah, so I think what it doesn't pass is the number of so we should have returned the number of small bricks if they are all used up, right? And here we calculate S, which is going to be less than small, I think. So if S is smaller, then return S. Otherwise, we should return small. We should, let's try it like this. And oh, okay, I got 5 minutes long, and maybe we should
Just make a change, one single, then you can watch, I guess.
What?
Make it equals, less equal or greater equal.
Oh, okay.
That means at line number second, go greater equal, and the same for goes line number if s less equal.
Oh, we just want like this.
Equal sign.
Small.
No, s less equal,
Okay, okay.
and else return small. Remove it.
Like this?
No, else return wala card.
Else
Yep.
return small.
Then remove it. Remove
Okay,
these two lines.
thank you. Okay, it's correct. Let's understand this code. We have just like 2 minutes. So we first want to evaluate whether we have not enough bricks, right? So goal is bigger than, oh no. So you want to ensure that the goal, we have some amount of small bricks necessary, and then you calculate how much we need here, yeah? And then if it's smaller, then we just return the number of bricks. Is it correct? Like you want to check if we need small bricks, then we calculate how much we need here, right?
Yes.
And if it's smaller, then we calculate what's the necessary amount. It looks
Small
like,
bricks we required.
yeah. So if s is smaller, that if one of these numbers is smaller than small, then we return
Or
s.
equal to the number of bricks of small. Like say if we got 4 small bricks, but we need 5. So that's return -1 because we don't have necessary number of bricks.
Yeah, for
So
example,
we-
in the second example, we have goal 10, which is bigger than 5 multiplied by 1. Yeah, so that's why we have s calculated. It's going to be 5. So
Yes.
because 5 is less than 5 is more bigger than 4, larger, yeah, that's why we have return -1. Yeah, I think it works
Exactly.
perfectly. Yeah, thank you
But
very much.
if we have number of small bricks 5, then it's return 0, I guess. No.
Yeah, I think
I'm not sure.
so if you have like the first example, if we have 9 divided by 9 is bigger than 5 multiplied by 1, and then we have 4 bricks here, and s is equal to small, that's why we return s. So anyway, no matter what s is equal to, we will return s as long as s is smaller or equal to a small. If
Exactly.
it's bigger, if we have more bricks than we have, then we return -1. If it's not clear for you, I recommend watching again the tutorial, the explanation. I will put the link here. And if after this tutorial is not clear, then we will discuss the solution next week. And I think next week we will cover the loops and more problems, more programming problems. Thank you very much for coming. Sorry for taking up so long, and see you next time.